Lately, development on prosthetic limbs has been focused on improving how the artificial limb functions. The problem with most prosthetic arms is that the user has to have the arm in their field of view in order to control it. Another concern is that many prosthetics cannot work for people who are quadriplegic or who have suffered a spinal cord injury, because most models use the spinal cord to transmit signals to the prosthetic. Research done by the Defense Advanced Military Research Project Agency, though, has set out to fix both of those problems. In a recent experiment, researchers there connected the prosthetic arm directly to not only the motor cortex of the subject, but directly to the sensory cortex as well. This allowed the fingers of the prosthetic to receive signals telling it to move, and the prosthetic was also able to send back signals to the sensory cortex, telling the brain what it was feeling as it touched objects. In the experiment, the subject was able to tell which fingers were being touched even when he was blindfolded, which is something that he would not be able to do with other prosthetic arms. To prove that even those with spinal cord problems could use this arm, DARPA chose to use a man who was paralyzed a decade ago because of a spinal cord injury. This experiment has opened the eyes of many researchers in the field, and many more outside DARPA have begun looking at alternative ways to replicate or improve the results from DARPA's experiment.